Hi and welcome to the Study Hacks Institute of GIS and Remote Sensing. So our registration is open for 7 days online training session on Google Earth Engine for remote sensing analysis for beginners to advanced level. Basically, this course I will try to teach you all of the things which you need to start with Google Earth Engine for remote sensing analysis. We mainly focus on all of the course content here you can see, and if you want you can join our online training for the 7 days private online training session. You can just contact with us WhatsApp number, as well as you can also contact with this email. Okay, so thank you.
Hi, sir.
Hello, can you hear me?
Yeah, pretty well.
Okay, so how are you?
Fine, man. And you?
Okay, I am fine, thank you.
Where are you from?
Oh, I am from Bangladesh, and
Bangladesh.
okay, and I from Brazil, yeah.
Yeah, Brazil. That's
Okay,
it.
okay. So
We are
basically,
cousins from the brick.
okay. So basically, in this time, I also try to share all of the method or algorithm which I created or developed this method for making the drought monitoring, as well as also for the flood mapping. I also share with you this method, not code, only for the methodology I will try to discuss with you. And after this, if you are interested to work with this, then you can also contact other details. Okay, so I simply share my
Okay.
screen.
So from the three that we have talked, you just have drought and floods.
Yeah.
Okay.
So
You don't have landslides
yeah,
detection.
only for the two things. And if actually in this time we already developed the two things for the drought monitoring and flood. And if you want, you can also join the if you want, you can also need the landslide, we can also develop it, no problem. So basically in this time, the drought monitoring and flood mapping is available, and we already work with the two things many time. Okay, so that's why I will share this procedure in this time. Okay.
Okay.
Okay, so can you see my screen now?
Pretty well. Yeah.
Okay. So basically, we can calculate the drought hazard index using the Google Earth Engine platform. So, so this is the main
Uh,
algorithm for making the drought hazard index. So mainly in this time, we can perform the only for the Google Earth Engine. Basically, this the algorithm is also make the web-based platform for drought monitoring or drought monitoring hazard. But in this time, we can also focus only for the remote sensing analysis, not move to the uh, web mapping or web application or GIS based web application, not focus in here. So here you can see mainly we calculated the hazard index, then exposure index, then vulnerability index. And we can get, you can see hazard index, we can get here the three data set. First data is the standardized precipitation index, then soil moisture index, then vegetation health index, then plumber severity index. Okay, so this is our we can get all of the index and calculated the
I,
hazard index.
I'm not familiar with Palmer. What's Palmer?
So for I also discuss all of the things. So because first of all,
Okay.
this is I can show the procedure, then move to the formula. Okay, or other details. Then you can see also, you can see exposure index. So mainly exposure index, here we use the land cover, and this is the elevation model. We can use here the land cover classification, as well as also you can use here the elevation model. And vulnerability index, mainly in this time here we use the labor force or household income, social. Actually this is the social part. Okay, so combine of the three index, hazard index, exposure index, and vulnerability index, we can determine the DSI. Okay, drought hazard
Mm-hmm.
index. Okay, so this is the
Okay.
algorithm, and you can see this is the formula. DRI, drought hazard index, is drought hazard index, drought vulnerability index, and drought exposure index. We can get the average result, and then we can classify the drought risk index. Okay, DRI.
Okay, let me share just one point with you.
Yeah.
That for Brazil, we have real bad maps if I use like Google Maps or Google Earth.
Yeah.
We have old mapping. Yeah.
Yeah.
What's the actualization, the update of those maps using Google Earth? It's better.
Yeah, Google Earth
So
Engine is the better because Google Earth is only focused on your raster vector data, but Google Earth Engine is focused the visualization and all of the algorithm for raster analysis or remote sensing analysis we can easily handle using the Google Earth Engine platform.
but you can verify the last satellite update, like the date, yeah, the
Yeah,
timestamp.
we can also get the satellite data, all of the things we can easily get from the Google Earth Engine platform, Google Earth Engine data catalog. We can easily get all of the things.
Okay, and you are telling that your delivery now is just the stage one.
Yeah, only stage 1 because this is the stage 2. You can see this is the platform for the, there is a another for the drought hazard web based application. Okay, so I can, in this time we can get only for the stage 1, and I'll explain the stage 1, all of the formula, all of the equation, what we can do,
Okay,
what's the satellite
but
image
you
we
you
use.
you already have this complete platform,
Yeah, it's
the
already,
three stage.
it's already completed, and we also make the drought hazard index web application, all of the it's already completed for the province of Pakistan. We can already completed this and develop this code.
Okay, and it's working.
uh,
It's in production.
okay, so first of all you can see it, first of all we need to select the time duration. So in this time we need to select the long term. We get the long term data set for a one satellite image, and we can also set here the short term. So mainly in this application we can get the 20 years data from the year up to 1998 from 2018, and get the shortest term data November to April. And then we also need to calculate the drought hazard index, GEE. So for this you can see we already discussed about this. So calculating the hazard index, we need to use here the standard precipitation index. Okay, mainly this data come from the CHARPS data. So here you use the CHARPS data for getting the SPI index or standardization precipitation index. Then you also see here the soil moisture index. So soil moisture index we can use here this NASA, USDA, SL, this data set for the soil moisture index. And you can also see the plumber drought severity index, PDSI. We can get the data from the you can see IDASQ. Actually all of the data set we can easily access from the Earth Engine data catalog. Okay, and then combine all of the SPI, SMI, VSI, PDSI, we can get the hazard index, calculating the drought hazard index. All of the index we can easily get, and all of the data set we can easily get from the our Earth Engine data catalog, from the sources CHARPS, NASA, IDSQ, all of the sources we can get this data.
Even for Brazil?
Yeah, even not only for the Brazil, you can get the data for the overall the whole world.
Okay.
So here you can see, and we can also classify some our specific drought list. Suppose extreme dry, severe dry, moderate dry, normal, and wet plant. So mainly when we classified our area, we can classes some area. This area is the extreme drought, this area is the severe drought, this area is the moderate drought, this area is the normal, and this area is the wet. We can classify there the total 5 classes and get the region. So then also you can see the standard precipitation index. So when you want to work with the standard precipitation index, so mainly this is our formula, and SPI is the based on the probability of the precipitation for any time scale, and this is the formula you can see. SPI, this formula is the latest precipitation subtract with the mean precipitation and divided by standardized deviation. So this is the formula for SPI drought classes. And here you can see we can also classify this SPI or standard precipitation index. We classified this index the 5 classes. So we can get here the less than 1, less than -2, -2 less than equal 1. You can see this is the, also I can write this here the -2, which pixel value it will be showing the 1. Or 1 you can see already classified the different time class, extreme dry or severe dry, moderate dry, normal dry, wet dry. And then using this classes list base, we can also classify this our SPI result. Okay, so getting the, suppose this pixel value, when I can get this pixel value, it will be showing the extreme dry or normal dry, okay, or moderate dry. You can see we can classify the 5 classes in here using the Google Earth Engine coding. We can just use the code and we can easily classify the SPI total 5 class. When this pixel value will be greater than equal -2 less than equal 1, it will be showing this result is the 1. You can see already defined, the 1 is that extreme dry. Okay, 1 for is the extreme dry, then 2 is the severe dry. And what is the condition for the 2? You can see when it will be greater than -2 and less than equal 1.5, okay, then it will be showing this result will be severe dry. Okay, so all of the index SPI or all of the index, we can classify the total 5 classes according to this pixel value. Okay, so
Okay.
then you can see soil moisture index. This is the same way. So we can
Okay.
use the dataset SMAP global soil moisture data for getting the soil moisture index. And you can see this is our classes. We can also classify this soil this data set into our 5 classes: extreme dry, severe dry, moderate dry, wet dry, and land. Okay, so we can classify this index, the 5 classes. Okay, then can divided, this region is the dry, extreme dry, like this. And this
Okay.
is the another for the plumber drought severity index, PDSI. We can get the same way for get the PDSI and classify the 5 classes. And after this we can also get here the vegetation health condition, VSI index.
Just come back to Palma. The Palma is the same.
Yeah,
The Palma.
yeah. So plumber we can also get the plumber dataset from the Google Earth Engine platform. And also you can see this is the
Okay.
VSI is the vegetation health condition. And this VSI, when you calculated the VSI or vegetation health condition, you also need to the VSI is the vegetation, you can see VCI vegetation condition index. Okay, and also need to the TSI is the temperature condition index. So VSI and this is the TSI. We can get the VCI. This is the formula for NDVI mean, thereby NDVI max, the mean. Okay, so this is our formula.
Okay.
And we can get the satellite data for the MODIS. And TCI, we can also get the satellite data for the MODIS. Okay, we can easily
Okay.
calculate the 2 equation. After this, we can calculate the VSI. You can see this is the VSI. This is the formula with the VSI. When I can get the VSI data, we can also classify the 5 classes, extreme dry, moderate dry, using based on their pixel value, and get the data of 5 classes. Okay, VSI, you can also calculate the 5 classes, and I based on their classes, extreme dry, moderate, normal. Okay, like this. And after this, when you calculated the hazard index, so calculated the hazard index, we can just, you can see, we can get the average result for the SPI class, SMI class, PDSI class, VSI class. Okay, all of the classes,
Okay.
we can get the average result. Okay, and we can see we can get the, this is the code for the you can see this is mainly, this is the equation, and this is the code for Earth Engine, which when I get the hazard index, we can simply add all of the things, all of the index we can simply add, and finally divide into the 4. Okay, then we can easily get this index. So and then when you want to also need to the hex hazard index, suppose this is the another method for the whole area, then we can easily simply write this code and we can get the hex hazard index. So basically you already done this, I'll write this code and also work with the Pakistan, also work with the Australia region for their identify the hazard. Okay, so basically if you want, you can also use this algorithm or method for calculated the hazard index in your area. Okay,
Okay. And this is a work that you need. This is a monitoring, yeah.
Yeah.
You need to keep it alive, the analysis. For that reason, I got interested about the entire framework when you send this to QGIS and Carto.
Okay, so if you want if you need the drought hazard web-based application, we can also provide it, no problem. Because when you need the web-based application, we can easily make the, okay, I also share with you some code or web application so that you can easily understand. So I simply open my code editor. So we already developed some application in here, make the different types of apps. So I simply go to my gallery. So here you can get all of the, you can see this is the agriculture drought in the rainfed tail in areas of the scenic the province. So this is the another for the Bangladesh drought monitoring. Actually all of the will be a web application. So this is the another web application for the water quality analysis using the Sentinel-2
What?
satellite imagery. Okay, water
Okay.
quality analysis apps. So all of the apps we already developed, and if you want you can also work with this on your region easily, you can do it. So in this time I also
Okay,
share with
but
this drought. Okay, so I
just
simply
some
open the
question.
drought. Okay,
Just one question. The quality of water, it's a different set of algorithms and applications.
so actually in this time when you want to work with the water quality analysis, we mainly try to observe the four index. So turbidity, chlorophyll and TSS, total suspended solid, then turbidity and chlorophyll. Okay, and basically in this time we use here the Sentinel-2, and we can also get the data, all of the data from the Sentinel imagery, and it will be vary from place to place. That's why it's not standardized for the overall the world, because some the topographic region or other based it will be some variation, but it's not the huge variation, it's the some little variation. We can easily do it for the, because but this is the more important, because now you can easily get the water quality analysis without going to physically with this region or water body, you can easily get. But this result is not the accurate, but this is the totally, we can say that this is the 80% accuracy will be available. Okay,
Okay, and it's easy to change the AOI.
suppose I want to choose suppose this is the lake, I want to observe this water quality from here, so I simply drag.
Could you try anything in Rio de Janeiro?
Yeah,
Rio de Janeiro, Brazil.
so do you want to work with this Brazil? Yeah,
Yeah, yeah.
so what is the place of this name?
It's RIO.
RIO.
Yeah, the first one.
Okay,
And let's say that we can select this. Could you see Jacarepaguá?
suppose I want to
Here.
select this area. Okay,
Okay, okay, good, good, good.
and we see, okay, this is my area, and I also select my specific time period. Suppose I simply select here the, suppose 29 January. Okay, from I randomly select this area. Not yet. So okay, and also select here the year of, suppose I simply put here 20 January. Okay, I select my drawer, and then I suppose I want to calculate the turbidity. I simply the turbidity and click to the submit, so we can see what's happened. Okay, so you can see we can get the only for this in this area, and this area is not covered with the our whole area which I selected. Okay, so basically it's
Okay.
depend on the some topographic region or other things, so that's why you can see we can get this result only for here. If you want to check the other things, suppose chlorophyll. Okay, so this is the chlorophyll. If you want to check the TSS, so this is the TSS.
Why do you think it's just limited to this area?
Okay, I think this area is the big, so we also take the small area and then try to again.
Okay.
Suppose you can get only for this area. Okay, so okay, so click to the submit. Okay, Okay, suppose I think now in some my networking issue, so that's why it will be not work properly. Wait a minute.
Okay.
So it's depend on a network connection. So okay. So what's the spelling of your region?
RIO. Rio.
Okay, Rio.
The first one.
Okay, so now I think it will be okay. You can see, also you can see this is the turbidity of these places. Also you can see time series analysis, when this turbidity will be high and when this turbidity will be low, we can get also, you can see time series data only for this region. Okay, if you want also check the chlorophyll and then submit. Now we can get this data for the chlorophyll between this time periods. Which time period I want to select here? Between this time period, you can get here the, you can see August 26 2021, this chlorophyll value is the 0.0033 and high you can see this is the 0.056. Also you can see the animation. I want to check here the turbidity or total suspended solid, so submit. So now you can see there is a lot of the total suspended solid will be available. Also you can see when it will be high, the August 26 we can get the total suspended solid value. Also you can see this is a low total suspended solid value. Okay, so here you can see, also see the near the urban area or other things, this water is not more clear, or you can see this here is the lot of the total suspended solid will be available here. Okay, and when you move to the river middle part or Bay of Bengal or other ocean, or move to the ocean, here you can get the total suspended solid, this value is the very low. Okay, so it indicates the their water is not good for the drink. Okay, so here you can see the lot of the total suspended solid will be available in here. Okay, so mainly application will be look like this. Okay, and when you want to the suppose you can see this is the another apps for the agriculture drought rain fed. So basically when you want to, basically in this time we can work with the some region. Okay, so you can see this is the district shape file, this is the district shape file, and we can also select our specific time period from here, and we can easily calculate the any index, which index you need. So you can see SPI index, SPEI index, VCI index, TACI index, all of the index we can easily get. Suppose I want to work with this region. For this A region I simply select, I want to observe the year of 2019. Okay, I want to observe here the what is the condition of the SPI. I want to measurement the drought using the SPI, and we already know about that. When you want to select the SPI, we already classified the 5 classes: extreme, moderate, severe. Okay, or like this we can severe it, classified all of the index. So I can simply click to the run. We can see what's happened. So okay, and here it also provide you the chart, what's the condition of the SPI on this year. Also it provided you this the hazard index, so when it map will become, we can easily understand. You can see extreme, severe, moderate, wet. Okay, so I think here my network connection is not so good, so it will be take some time. So here you can see this is our chart for this SPI time series for the year of 2019. So it will be working.
Yeah, for the hazard I think it's pretty good. The only gap that I can see is landslide detection.
Yeah.
Okay,
Yeah.
And the water quality, it's interesting too.
Yeah.
And I would like to see the app. When you talk about the app, you are meaning Earth Engine apps or a completely web application?
Yeah. So this is the completely web application using the totally Google Earth Engine platform or Earth Engine platform.
And you do any statistical analysis using Carto nowadays or not? It's just the pixel calculation.
Yeah.
Because in the first presentation there is a Carto solution, yeah, the stage 3.
Yeah. Yeah. So basically in this time we can also create the web application using the Google Earth Engine platform. We don't need to move to the QGIS software or other things. We can easily make the web application using the Google Earth Engine platform and work with this.
Okay,
And anyone can using the application from this link and also get the source code is not available in here, so because we can only provide this the source code which you want to buy this, so we can also only provide it him so that he can easily change any modification on this code and easily work with this. Okay.
okay, but your delivery, you deliver the source code, yeah?
Source codes, as well as if you want you can also I also make you the this like the your link. Suppose you can see this is the link, anyone can access the application using the link. So if you are not able
Okay,
to, I also try to show you that, and I also try to teach you how you can easily make the Earth Engine app. So when I will send you this code, then I also take a live class for you so that you can how you can easily make the Earth Engine app using your own user ID. You can see in this
I
time it
got
will be
it.
showing my user ID. Okay.
I
So I
got it.
also try to show you that how you can easily make your own user ID for making this your web application link.
I got your point. I got
Okay.
your point. See, what I have right now is what I need right now is like something to do a presentation. Okay, I don't have a project
Yeah.
right now,
Yeah.
and what I need is to like do a POC or present some like hazard index,
Yeah.
the way it works, the application, just a pre-sales, yeah.
Yeah.
Just that's my point. Uh, how we can do it? Let me see.
So if you
Hmm.
want, you can also make the web application easily using the Google Earth Engine platform. And if you want, you can also his algorithm. I will try to show you that you can also implement this algorithm in your area for easily make the drought hazard index.
Okay. The landslide, how much time do you take to
So
develop the
within
landslide?
landslide, I think I need some time because I also need to read the some scientific paper or journal
Yeah,
for what
yeah.
is the algorithm they are used. Then I simply take the algorithm from this journal, and then I easily implement this code in Earth Engine platform.
Yeah.
And you can see
Could
the
you also share
yeah.
all the papers that you use as a background to develop
Okay, okay,
the
no
algorithm?
problem. I also share you all of the papers so that you can also easily understand. So the basically all of the algorithm we can take from the another paper, because this paper is not this paper will be used for the traditional software, just ArcMap or QGIS. They are not using the any coding. Okay, so in this time we can easily implement all of this previous paperwork, easily implement in the code using the Earth Engine. So that's why it will be very quickly and efficiently we can do it using the Google Earth Engine
Okay.
platform.
And it's easy to integrate the ArcGIS with all these Google Earth Engine APIs
Yeah.
if I want to. Yeah.
Okay,
Okay.
no problem. Yeah.
Okay.
And this is
So
the
estimate for me the time and effort for the landslide.
okay. Okay, no
Okay.
problem. As soon as possible, I also try to show you the algorithm for the landslide which I develop, and for this I also need to some study about the landslide, and I also as soon as possible I also knock you, no problem. And this is the more algorithm for the flood mapping. Mainly in this time here we use the Sentinel-1 satellite imagery. Okay. So this is the algorithm.
Okay.
This code already developed. We can easily use for this the damage assessment, mainly the urban areas, then cropland damage assessment, as well as also exposure. Okay, exposed population, affected cropland, affected urban areas, all of the things we can easily calculate it, the area. Then we can easily make the flood map with damage assessment using the Sentinel-1 imagery.
Oh, so you do a damage assessment.
Yeah, damage assessment. This is the flood map with damage assessment.
And how do you present this damage assessment?
So mainly in this time I also try to explain this method. So first of all, flood mapping. We can get the flood mapping using the Sentinel-1 satellite imagery, and all of the correction or the automatic processing we can easily do. Then we can get the image, this Sentinel-1 image. We can get the two period. First period is the before flood, then after flood. We can get the two period. Then we can get here the change detection. What is the change between the first period and before flood and after flood? Okay. Then we can use a threshold, okay, or binary flood extent. We can easily do. Then we can also use here the dam data. So we can exclude the areas with the less than 5% slope. Then we can get the exclude the permanent water. So we can get all of the data set for the dam, then global surface water. We can get all of the data set from our Earth Engine data catalog. Okay. Then we can also use here the intersect all of the layer using the population density. Then we can also make the cropland land cover classification for the cropland. Then also make the urban areas identify on our region. Then we can easily expose the population, affected cropland and urban areas. After this, we can calculate it how many population will be exposed in for the flood, how many urban or cropland will be affected, how many area will be affected for the cropland or urban areas for this flood. After this, all of the things we can identify the flood map with the damage assessment. What is the damage will be happened in here. So mainly in this time here we can get the three damage. First damage is the urban areas, then affected cropland, then exposed population. After this we can calculate it all of the area, how many cropland will be affected, how many area of the urban areas will be affected, how many exposed population will be affected. Get calculated all of the area. Then we can easily identify the flood map with damage assessment.
Okay, and from where you get the density population?
So mainly it's depend on your region. So we can get this data from your region, as well as Google Earth Engine has some data catalog. They are also provide the density data, population density data.
Okay. For instance, I have the KML for the Rio de Janeiro state. So we can do like a catalog of those analysis for the state of Rio de Janeiro, right?
Okay, no problem. You can send me this KML file, and then I can easily import this KML file in our Earth Engine platform, then work with this, no problem. For the flood mapping, then drought monitoring, all of the things we can easily do it, no problem. Okay. And landslide, I also...
Could you list? Yeah. Could you make a list of all the analysis that you have ready, like the water quality, water quality, what's the others?
Okay, so water quality, then flood mapping, damage assessment, then drought monitoring, the three things, yeah?
Yeah. Okay. Do you have any additional one or not?
So actually in this time I also need to do some algorithm for the landslide, because this is not present in this time. But water quality, then flood mapping, damage assessment, and drought monitoring is available in this time. So I can get some time, because I also need some time for the landslide. Then we can easily get all of that output for your own region. You can also send me your KML file so that I also work with this. Okay.
Okay, great. And there is any other study that you're doing in this area of remote sensing?
So actually we can do the different types of algorithm. Actually Google Earth Engine is a platform. In this platform we can do any remote sensing analysis. Just we should need to know about the algorithm. What is the algorithm of your process of this work? Then we can easily implement all of the work in here. So I also make the...
Do you have anything in agriculture area?
Okay, so you can also see this is the another things for the enhanced vegetation index and normalized vegetation index. So mainly this is the another web application. So in this application we can easily access the determine for the Bangladesh what's the trend, for the NDVI and EVI on this any specific place. Suppose in this time I want to check for this area, I simply click on this area on the map of this Bangladesh. Now it will be showing here the this area lat long, what is the coordinate, also provide you this, you can see this is the what is the EVI and what is the NDVI change. We can also get this time series chart. Okay. Okay, so and there is a lot of work in Google Earth Engine platform. I also try to show you that. So we can also do here the NDVI plant health status. Okay, I also share you the project work, all of the project work using the Google Earth Engine platform, so that you can easily understand. So I open my slide, just a minute.
So you also do this training?
Yeah, I also provide the different types of 7 days, 5 days, 3 days training. I have a online institution. So from this online institution, from the different from the overall all of the country who are interested to work with the remote sensing and geoscience, they are easily join with my online training, and they are easily get the all of the course content. Also they can easily learn of the Google Earth Engine platform, all of the things. Okay.
Oh, great.
So I share my project work with you so that you can. So I also share my some research and project work which I done with the Google Earth Engine platform. So first of all, you can see this is the chart NDVI over time in period. So we can easily get the NDVI chart over a period of time from any specific location. When you want to click on this map, we can easily get this data. And this is the web application link. Anyone can easily access the link and get the data. What is the condition of the NDVI or normalized difference vegetation index. So this is the another things for the modis leaf area index. So basically in this time we can easily get the leaf area index with the time series analysis. Okay, so we can easily get the draw your ROI, then you can easily get this data. And this is the link, web application link. From the link we can easily access this web application. Okay, so this is the another things for the NDVI and EVI. I already tried to show you that part. And this is the web application link. So this is the another things for the precipitation measurement map. We can also do this map using the Google Earth Engine platform year of 2020 for Bangladesh. So here you can see this is the more rainfall will be happened in the Sylhet district. So this is the part. So this part there is the more of the precipitation will be happened in here. And this precipitation unit is the millimeter per hour. So how we can get here the total 1 year of 2020 average precipitation map. So this is the another things for the land surface temperature. So this is the land surface temperature map for the year of 2020. Here you use the Landsat 8 satellite imagery. And this is the another things for the land cover classification map, land use and land cover classification map for the whole country boundary of Bangladesh. And this is the web application link. You can easily access the link and get the better view of the land cover classification map of Bangladesh.
Great.
This is another things for the assessment of the plant health status in the year of 2020. So in this time here you can see some the hill track area will be showing at the gray color, and where the dense vegetation or forest we can get the some green pixel value for the country purpose of Bangladesh. And also you can see some the capital of the country or the urban, you can also see that there is the no vegetation. Okay, so mainly here you use the NDVI for assessment of the health status. So this is the another for the water quality monitoring using the Google Earth Engine platform. And in this time we can estimate the turbidity. Okay, we can estimate the turbidity using the NDTI in Hathirji Lake in Dhaka city. It will be studied in Dhaka city. So mainly we can see we can use this algorithm. So first of all we can get the multi spectral remote sensing data for Sentinel-2. Then we can easily calculate it the water index, normalized defined water index using this formula. Then we can max water pixel then we can easily change the reflectance is visible and infrared bands. Then we can also get here the NDTI. Okay, so NDTI
Okay.
it's the change determine the change in turbidity. Okay, so this is another things for the nitrogen dioxide concentration. So here you can see we can also do using the Google Earth Engine platform for the air quality monitoring. So it also possible for making the air quality monitoring map using the Google Earth Engine platform. So we can also do here the 2 period of time in Bangladesh country. So observing the air quality monitoring specific nitrogen dioxide concentration. If you want, you can also calculate the carbon monoxide, formaldehyde, ozone, all of the gases which will be available in the Sentinel-5 satellite imagery. We can easily make the map using the Google Earth Engine platform. Okay.
Okay,
So
great.
this is the another for the cropland classification map. So mainly in this time we can get the cropland classification map using the multi-sensor remote sensing data, and here we can get the classified for the non-cropland, then cropland irrigation major, then cropland irrigation minor, then cropland rainfed minor fragments. All of the classified we can get from here. So this is the another for the flood mapping. So mainly in this time we can get here the 2 season. One season is the dry season and wet season, and then we can easily perform the NDWI for determine the water, what's the condition of the water. So here you can see the a map. Then map will be defined the wet season and dry season. We can also do in the Google Earth Engine platform. So this is the another map, and it's very interesting. So here you can see this is a night light map activity. So mainly in this map we can see when the night time you can see this pixel value showing as a black color. For the forest you can see this is the you can see this is the part for Bangladesh. This is the mangrove forest, and you can see this is the mangrove forest. There is the no light in the night time. Also you can see some the hill track area, there is a no light, and also you can see some the river. So this is the river part, river. Okay, also you can see some the forest, and there is a totally actually this data set provide you the night time activity. You can see this is our capital, this is the capital of Dhaka city, and there is the all time in the night time activity will be very high. All the other district or major city you can see there is the light in the night time, but you can also see some the forest, mangrove forest, hill track area, also some forest, also some river, there is the no light. So this map is mainly identify the night light map of activity in the night time, and we can also do using the Google Earth Engine platform. And this is the another things for the gross primary production. So we can easily use the Sundarban area for mangrove forest area for get the annual gross primary production for the 3 different year of 2000, year of 2010, 2020. We can get all of the change trend forest in GPP gross primary production using the Google Earth Engine platform. And if you want, you can also get here the NPP or GPP, then gross primary production, then biomass. All of that we can easily do using the Google Earth Engine platform. Then biomass carbon we can easily using the Google Earth Engine platform. And this is the another for the relationship between the land surface temperature, then normalized difference built up index, and normalized difference vegetation index for the year of 2020 and 2016. So mainly this is the another research work. So this is the another for the detecting the wildfires in California. So you can see easily identify the wildfire in a forest area. We can easily identify using the satellite remote sensing technique. So this is the detecting the wildfires in California. We can also do Google Earth Engine platform. You can see I also make the Earth Engine web application map. Anyone can easily get this app.
Okay.
So this is the another things for the drought monitoring using the standard vegetation index or SVI for the purpose of Bangladesh. So we can easily using the algorithm for the Bangladesh and get the drought monitoring using the standard vegetation index or SVI. And this is the web application. Anyone can access the web application. And this is the spectral unmixing model using the Google Earth Engine. So mainly here I use the linear spectral unmixing model, and then I can easily identify the vegetation, bare land and water only for the 3 classes using the linear spectral mixing model. This is the another map for the snow cover of the Iceland, and we can also measurement the how many snow will be vary from the year to year. We can easily using the Google Earth Engine platform. So this is the another things for the land cover classification map of a district in Bangladesh. So you can easily use the ground truth data, and we can easily get the different types of, you can see the homestead, settlement, crop, then fallow land, then forest and water. Also we can calculate it how many water area will be available, how many forest will be available, how many fallow land will be available, how many cropland will be available. All of the things we can calculate it in hectare unit.
I
Also you can
see.
see this is the crop classification map in Punjab, so we can easily year of 2070 for the Punjab we can get the wheat, the maize, the fodder, then rice, then cotton, all of the crop we can easily make the classification, and we can also get the area, how many area will be cultivate the rice, how many area will be cultivate the cotton, how many area will be cultivate the maize. All of the crops we can easily classification and also get the result, okay, using the Google Earth Engine platform. So this
Okay.
is the another map for our research work. So this is the actually this is the air quality monitoring or air quality parameter, nitrogen dioxide concentration in the Dhaka district, the different 3 period for the pre-lockdown, lockdown and post lockdown in the COVID situation. We can also measurement the 3 different time period, how many nitrogen dioxide density will be vary from the year to year, okay, from the period, okay.
Okay.
So this is another things for the classified the land cover classification map of the Bhasan Chor. So using the Google Earth Engine platform. So this is the elevation map of Bangladesh. We can also do using the
Mhm.
Google Earth Engine platform. Actually, all of the remote sensing work we can easily do using the Google Earth Engine platform, and we can get the very quickly and efficiently than other software, just ArcMap or QGIS. Google Earth Engine is the very latest and technology, and we can easily do the different types of remote sensing analysis using this. So this is another things for the land surface temperature classification map year of 2050 to 2070. We can classify the some sub low temperature, sub low, sub high and high temperature, okay. So we can easily classify it using the Google Earth Engine platform for the land surface temperature. So okay, okay, just it. So actually there are a lot of application or lot of work we can
Yeah,
easily do the Google
there
Earth
are.
Engine platform. Just we should know what is the algorithm and what is the formula of the algorithm, then we can easily implement in our code editor, and we can get easily all of the data from the Earth Engine data catalog, then work with it, okay.
Okay. And also use as backend APIs to the GIS, yeah?
Yeah,
Yeah, I think that's important point.
yeah.
Do you have any web application outside Google Earth?
So mainly in this time, I also only work for the Google Earth Engine platform, and
Okay.
recently we also work with the using the Angular JavaScript or JS for making the turn the Google Earth Engine web application into the another website. So for this, we also need to use here the Angular JavaScript or Angular JS. So we can easily when
I
it will
see.
be done, then we can easily move any website we can show the Google Earth Engine web application, just a app, okay. We can easily was using the Angular JavaScript or Angular JS.
Okay, great. And another point, how Google charge for this analysis? It's charged or not?
Actually it's totally free, so it's totally free to charge for your analysis. So all of the analysis will be free, all of the data set will be free, all of the data catalog will be free, all of the things will be free. Just you need to sign up.
Okay.
After the sign up at the Earth Engine, you can get the code editor like this. You can see I already signed
Yeah,
up.
yeah,
So
I have it.
okay,
I have it. I have already used it.
okay, so then we can easily get all of the data, all of the algorithm, we can write the code, all of the equation, all of the chart we can easily get from the Earth Engine data catalog, okay.
Okay.
And I also
So
provide
let,
the some courses on Google Earth Engine platform. Recently this registration will be opened for the big 7 days online training program on Google Earth Engine platform from the beginners to advanced level. So we completed all of the course content. So our registration is open, so anyone can interested, they can easily join with us, and this is a totally private training program, okay. So only one person join with me, and he can learn with me lifetime teaching support, okay. After 7 days, when he
okay.
face any problem, then he can contact with me and get the solution, okay. So if you are interested to learn, you can also join with us and learn. And basically in this time I have in this time the more than 100 students, they are already take the training for the different types of the beginners, advanced and other research purpose training. They are already taken from our institution Study Hacks, okay. So this is the Institute of GIS and Remote
Okay.
Sensing, and I also provide you all of the project work as well as from the Fiverr. We also provide the project work for the different types of research work, okay.
Okay, great. Yeah, I'm gonna share with you the KML. Estimate for me the time to have the landslide analysis,
Okay.
and I will think how we can do like a presentation here in Rio for some people. And
Okay.
I'm gonna ask you the best way. I don't know. The idea was to have like a presentation exactly what you have done to me for Rio de Janeiro, you see, or for a specific area.
Yeah.
Just like a teaser, yeah.
Yeah. Yeah.
What we can do, what we can deliver, yeah.
Yeah. Yeah. So
But
basically, this is
let's
the
think about
specific
the
area.
best way.
Yeah.
Yeah, yeah. Okay. And let's
And
see.
and
Analyze
i-
this
and
KML
if
and
you have any own algorithm, suppose if you have any own algorithm, you can also send me this. I also easily implement the code in Earth Engine platform, no problem. Okay.
okay, great, great, great. Okay, man. Very
Okay.
beautiful work.
Okay. Thank
Yeah,
you.
be proud of it. Be proud of it. It's very high quality. I like it so
Thank you.
much.
Thank you.
Let's see how we can make some deal. Okay.
Okay.
I'm gonna share with you the KML and you keep in touch using the
Okay.
fever.
Thank you.
Let me just take your contact detail. Yeah, I got it.
Okay. So I will
Okay.
just send you this contact in here. So do you have used the WhatsApp?
Yes, yes. Let me put here
Okay.
chat.
I will just send you in here because some the restriction in the Fiverr.
Yeah, it's very bad. Yeah.
So this is
My
my
name,
WhatsApp number, and I also save you this number in here. No problem.
my
Okay.
name and my email account.
Okay. Thank you. Okay.
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 Thank you so much, gentlemen. Have a great day.
Okay. Thank you. Okay. Good day.
Bye bye.
Bye bye.